Good morning, everyone. Happy Friday. This is your second to last bit of content on networks. So we are now looking at shortest connection problems. This is probably the easiest one and my favorite too. So if we have a look at this diagram here, let me get my little pointer up here. So you can see down here there's a tap, and then each of these nodes represent a sprinkler. And then these lines here represent the pipes from the tap to the sprinkler. So we've got 4 pipes coming directly off each, connecting the tap to each of the sprinklers. Now, they're all connected, so that's good, but this isn't the most efficient way to connect all the sprinklers. It uses too much piping, and you can actually connect sprinklers to other sprinklers. So if we have a look at method 2 here, this one would be more efficient because it's got the shortest connection between all of the points. So we've got our 4 sprinklers plus our tap all connected. All right, and shortest connection problems always make a spanning tree. So this is an example of what a shortest connection problem is. So there's 2 methods, and I'm going to go over them both in this video because they're pretty quick. The first one is Prim's algorithm, and the second one is called Kruskal's algorithm. I think that's how you say it. So let's have a look at Prim's algorithm first. So to start off with, you start with any node. So here you can see I've circled C, so I'm going to start with C. Then you join this node to the nearest node. So I've got 4 nodes coming off of C, and the closest one is 6. So I am going to join it to 6. If I had 2 or more that were in equal distance, you would just randomly choose one. Then, once you've done that, then you join the node which is nearest to either of the nodes that are already connected. So here I've got 27 coming off B, or I've got 12, 14, and 18. So I will be choosing the 12. Again, now I have 3 nodes connected, so I'm looking at the shortest one that comes off of those 3 connected nodes, which will be... it should be, so we're going to continue joining the nodes, 14. Alright, so now I've got 4 nodes connected, and the shortest one coming off is this 9 here. Then the next shortest one will be 5, and then the final one will be 11 here. So we've made a spanning tree, and the minimum length to connect all the nodes is 57. Hold on a second, I've got to let my dog out. So that is how you do Prim's algorithm. Pretty straightforward. So I have some questions here, so I want you to do 1A and C, question 2, 3, and 6. So it'd be good to get either the first 3 or the last 3 done at a minimum. All right, now quickly moving through, now we're going to have a look at Kruskal's algorithm. I'm not really sure how to pronounce it. It's very similar to Prim's algorithm, but with Prim's algorithm we were looking at the nodes. We are now looking at the edge values instead. So you start with the shortest edge in the entire network. So if I'm looking here, the shortest one is 2. Again, if you had 2 that were the same, you would just pick one at random. Then you choose the next shortest edge in the network without making a circuit, and you keep doing that until all the nodes are connected. So if I'm looking here, my next shortest one would be this 3 or this 3, and at random I chose this one. Then my next shortest one would be the 3 again, then it would be the 4, so I still need to somehow connect this node here, and these 2. So my next shortest one will be 5. Now I have this 5 here, but that would make a circuit, so I wouldn't do that one. And I have this 5 here or this 5 here, so it doesn't matter which one I connect here, so I'm going to do this one. Now again, I still have my 2 5s, but they would make circuits, so I'm not going to use them. So my next shortest one is the 6, and now I have a spanning tree for my shortest connection. Now, there are two solutions to this because, like I said here, I could have just as easily done this one here. So my solution would have been this or this one here, and they would both be valid. All right, and then the questions that I want you guys to do here are on page 428, question 1, A and C, 2, 4, and 5. All right, let me know if you have any questions, and we are almost done with this topic. Good luck and have a great weekend. Bye.